Hello my schoolers, welcome to my school channel. We'll be tackling the JAMB 2019 past question for physics. So, in this clip, we'll be solving questions number 41 to number 60. So make sure you follow through every step-by-step solution that we prefer to each question. So join me as we tackle question number 41. When water is boiling, it does what? Okay, so boiling starts from the lowest point in your pot. Why? Because that is the source, or that is the part closest to the heat source. So those ones gain energy, okay, and they move up. So as they move up, the ones without the energy, they go down. The ones with energy, the excited molecules, they come up. The others, they come down. Okay, that is how the whole reaction, the whole process goes on. After that, you will now see that they cannot retain or remain as liquids again because of the kinetic energy these molecules has gained through it, and they begin to escape as water vapor. Okay, and that becomes your steam. They vaporize into the air. So all of this explanation just sums up to when water is boiling, it changes to steam. Option D is very correct. Question 42. A mixture of blue and red pigments, when illuminated by white light, will appear as what? So we know that green is a mixture between blue and yellow. Okay? Orange is a mixture between red and yellow. Okay? Yellow is a mixture between red and green. Okay? Then magenta is a mixture between blue and red in equal amount. So option D is very correct. Over to question 43. A siren having a ring of 200 O makes 132 revolutions per minute. A jet of air is directed on the set of O's. Calculate the frequency and wavelength in air of the notes produced. Okay, so we can take it like this, that frequency equals the spin rate, okay, times the number of O's. Okay, so we have the spin rate as 132 revolutions per minute, okay, times the number of O's, which is 200. Okay, remember 132 minutes, that is, if you divide it by 60, okay, 60 seconds make 1 minute, 60 minutes makes 1 hour. So if you divide this by 60, so we are going to have somewhat around 2.2, that is 2 hours 2 minutes. 120 minutes equals to 2 hours. Okay, that is why we did this. Okay, times 200, very easy. So what we are going to have is 440 hours. Okay, that's the unit for frequency. So we have gotten frequency and we are required to find the wavelength. So recall our formula V equals F lambda. The lambda here stands for the wavelength. Okay, so dividing both sides by F, because we have to make the wavelength the subject of formula. So that implies that lambda equals V, and we are given V from our question as 350 meters per second. That's 350, okay, over our frequency that we have gotten as 440. So when we divide through, we should have our lambda as 0.795. Okay, this is wavelength. It is measured in meters. So let's go through our options together and see which of them is correct. Okay, so option A is very correct. So by now, I believe you are already preparing by using our Myschool tools to help you increase confidence and competence towards your coming exams. Perhaps you haven't joined the winning league. Remember that you can get the Myschool mobile app or purchase the Myschool software so that you can have a simulated JAMB CBT practice experience. I have provided you with the link in the description below where you'll be taken to the Myschool website, and you can download the Myschool app or get the Myschool software. So let's still go over and tackle question number 44. A man on a bench will exert the greatest pressure on the bench when he does what? Okay, so remember that pressure is force over area. So the lesser the area, the more the amount of pressure you will experience. Okay, so for you to reduce area and increase pressure, what you just have to do is the amount of area that the man will be placing on the bench must be smaller, far smaller compared to the force he's applying. So to feel the pressure, if he lies flat on his back, that means there will be lesser pressure because much area is being expanded on the bench. So option B, when he lies flat on his belly, of course, you can see his torso is on the bench. So area is increased, therefore pressure will decrease. Option C, when he stands on both feet, of course, he has reduced areas, okay, standing on both feet. But let's compare what we have in option D. It stands on the toes of one foot. So he has really reduced area to just 1 foot with the same amount of force, and that means pressure is going to increase because pressure equals force over area. So the lesser the area compared to the force, the more the pressure you are going to feel. So option D is very correct. So don't forget to hit the like button, click on the subscribe button, and tap on bell notifications so you can get informed as we release the next videos just for you. So now to question number 45. Gases conduct electricity under what conditions? Okay, so at first we should know that on their own, gases are poor conductors of electricity. But when we alter certain conditions, they can conduct electricity. And that is what we are looking at in this question. So under low pressure and high voltage, they will conduct electricity. Why did I say that? At low pressure, not too low pressure, you know, when pressure is low, volume will increase. That means there is enough space in the container for these atoms to move and collide with one another. In the process of the collision, the voltage supplied creates a kind of electric field that allows the atoms to ionize. Okay, and that is what gives rise to the passage or the conduction of electricity. So at low pressure and high voltage, gases will conduct electricity. So option D is very correct. Here we have question number 46. Neutrons were discovered by who? Okay, this is Michael Faraday. He talks about the laws of electrolysis. John Dalton brought out the theory of atomism, that is the atomic theory. James Chadwick discovered neutrons in 1932 when he bombarded a beryllium atom with alpha particles, and he realized that there wasn't much deflection. There was a negligible amount of deflection. So he said definitely there must be another particle inside the nucleus of an atom which is neutral and also quite heavier than the proton. So James Chadwick in 1932 discovered neutrons, and this is Ernest Rutherford. He discovered proton and the nucleus. So option C is very correct. So we have question number 47. The mass of a nucleus is the what? Option A, total number of its protons and neutrons. B, number of its protons. C, mass of its electron. D, total number of its protons and electrons. So when you talk about a nucleus, the particles inside, they are the proton and the neutron. So if you want to measure the mass of the nucleus, that talks about the constituents, which are protons and neutrons. So option A, the mass of a nucleus is the total number of its proton and neutrons. So option A is correct. So do not forget that several solution providers are waiting for you on the Myschool website to ask your questions right now. Just as you have indicated in the comment section below about questions that you have or clarity that you need, I have provided you with a link in the description below where you can ask those questions right now, and those solution providers on the Myschool website will be right there waiting for you. So join me as we tackle question number 48. 3 resistors with resistance 200 ohms, 500 ohms and 1 kilo ohms are connected in series. A 6-volt battery is connected to either end of the combination. Calculate the potential difference between the ends of 200 ohm resistance. So just recall that when resistance are arranged in series, or when the resistors are arranged in series, the resistance we are trying to work with are arranged in series. Okay, this is what we are going to have. R total equals R1 plus R2 plus R3. Okay, if it is arranged in parallel, in case of questions you may meet in your common exams, if it's in parallel, we have 1 over R total equals to 1 over R1 plus 1 over R2 plus 1 over R3. Okay, this is just tips for you. So since we are dealing with series, our R total will be the first being 200 ohms, okay, plus the next being 500 ohms, and the third being 1 kilo ohms. A kilo is 1,000, so 1 times 1,000, that is 1,000. So if we add up, this will give us 1,700 ohms. Okay, so we are now asked to find the potential difference when it is connected to 200 ohms resistance, or resistor rather. Okay, so this is the 200 ohms. We are asked to find the PD of these 200 ohms, okay, out of the total resistance, which is 1,700, okay, multiplied by the battery connected to it, which is 6-volt battery. Okay, so this strikes this, this strikes this. 2 times 6, that gives you 12 over 17. 12 divided by 17, that gives us 0.705882 and thereabouts. So if we just approximate this, okay, that should give us 0.71, or bringing it to 2 decimal places. Okay, so this is what we are going to have. Potential difference is measured in volts. So let's go through our options together. We can see that option A is correct. So don't forget that at any point through all of the questions we have solved so far, you have better steps or explanation that you can recommend. Please let me know by indicating the question number and the solution you'd like to share in the comment section below. So we have question number 49. An AC of 1 ampere at a frequency of 800 cycles per second flows through a coil, the inductance of which is 2.5 millihenries, okay, and the resistance of which is 5 ohms. What is the power absorbed in the coil? So that's very easy to solve. The formula for power, okay, in this context or in this question we have to solve is current, okay, times the potential difference or the voltage. Okay, then recall that V equals IR. That is current times your resistance. Okay, so that is IR. So P, the power, equals I times I, that is I squared times R. And our current I is 1 ampere, so that is 1 times the resistance that we have here is just 5 ohms. So, and power is measured in watts. So our answer is 5 watts. Option A is correct. Here at question 50, in semiconductors, the carrier of current at room temperature are, okay, they are definitely electrons and holes. Why do we have electrons and holes? Because we have the N-type semiconductors and we have the P-type semiconductors. The N-type semiconductors, they carry current in the form of electrons, okay, which are negatively charged particles. While for the P-type, they carry current, okay, as holes, and these holes has a charge that is equal and opposite to what an electron is. So, in summary, in semiconductors, they are being carried through the electrons and holes. So option B is correct. Question 51. Water and kerosene are drawn respectively into the two limbs of a air apparatus. The density of water is 1.0 gram per cm cube and the density of kerosene is 0.80 gram per cm cube if the height of the water column is 20.0 centimeter. Calculate the height of the kerosene column. So that's very easy. Okay, S apparatus is used to compare the densities, relative densities of two liquids. So we have for kerosene and for water. So for water, we are going to have the density, okay, times the height, okay, equals to the density of the kerosene times height of the kerosene column in the S apparatus. So we have density of water as 1 times the height from the question we are given. We have the height in the water column as 20 equals, we are asked to find the height of the kerosene column times the density of kerosene, which is 0.80. So what do? We divide both sides by the coefficient, which is 0.80. So that implies H2, that is the height of the kerosene column, okay, equals 1 times 20, that is 20, isn't it, over 0.80. This still means 20 over 1 divided by 8 over 10 or 80 over 100, whichever one works for you, okay? So 0 strikes out 0, so we still have 8 over 10 equals 20 over 1 times 10 over 8. Okay, so we have it here. This is 200 over 8. 4 year 2, 4 year 50. Okay, 2 year 1, 2 year 25. So the height of the kerosene column is 25 centimeter. So join me as we scan through our options. So option D is correct. So we have question 52. When a girl moves towards a plane mirror at a speed of 4.0 meters per second, the distance between the girl and her image reduces at a speed of what? Okay, so this is very easy to do. Of course, you can employ the formula of velocity equals to distance over time, but I'm going to make this as easy as possible. Okay, just think about this, a plane mirror. Okay, so this is the girl. Let me just represent her using a circle, okay, or a sphere. So let this be our image. Okay, of course, you agree with me that there are no accuracy or right dimensions to whatever figure we are producing here. It's just explanatory. So this is the girl, okay, and this is our image. So we are told that the speed between the girl and, you said that when the girl moves towards a plane mirror at a speed of 4.0 meters per second. So the speed between the girl and the mirror is 4, isn't it? From here to here. That is 4. Okay. And remember that image distance equals object distance. That is using a plane mirror. So if from here to here is 4, definitely from here to here will be 4. Okay? So if the distance between the girl and the mirror is x, definitely the distance between the image and the mirror will still be x. So if we want to say, we can say fully that the distance between the girl and our image will be x plus x, that is 2x. The velocity or the speed between the girl and our image will be 4 plus 4, and that gives you 8. So the correct answer is 8. So option C is very correct. So here we have question number 53. 1 Newton times 1 meter equals what? Okay, we know that Newton is the unit for force. Okay, meter is the unit for distance. So this means force times distance, and work done equals force times distance. And the unit for work done is measured in joule. So 1 Newton times 1 meter equals 1 joule, which is the unit for work done or energy. So option B is correct. So don't forget that you can use our simulated JAMB CBT exam tools that we have provided just for you. So you can either download the JAMB Myschool mobile app, or you can get the JAMB Myschool software. I've also provided you with a link in the description below where you can get any of these tools. So let's tackle question number 54. A microscope is focused on a mark on a table. When the mark is covered by a plate of glass 2 meters thick, the microscope has to be raised 0.67 centimeter for the mark to be once more in focus. Okay, so calculate the refractive index. That is very easy to do. Recall that the shift in the microscope equals that upward raise, okay, in the mark. Is that okay? So we know that the microscope rather was shifted 0.67, okay? And the upward raising mark first talks about the thickness of the glass, and the glass is 2 meters thick, into brackets, okay? 1 minus the inverse of index, n. Is that okay? So the first thing we are going to do, you can divide both sides by 2. Isn't it? So we have 0.67 over 2. Is that right? So if we want to make refractive index positive, we can bring the refractive index to this side, okay, and send this to this side. So if we are going to do that, just follow me. That's going to be very super easy. So already we've gotten this as 0.67 over 2. So we are sending it to the right hand side. It's going to become negative, okay? Bringing the refractive index to this side is going to become positive. That's just to make our work faster, okay? So we have 1 over n equals, okay, 0, okay, first we have this 1 here. This 1, when this comes in, becomes negative. Isn't it? then we have this as the LCM. This is super easy. So we have 1 over n equals the LCM being 2. Okay, so 2, that is 2 times 1, that is 2, minus 2 into, that is 1. 1 times this, that is 0.67. So if we transfer this, we have 1 over n, okay, equals 2 minus 0.67, that is 1.33, okay, over 2. If we cross multiply, we'll have 2 times 1 equals n times 1.33. So dividing both sides, so this should give you 1.503 whatever equals the refractive index. So if we just want to bring it to 2 decimal places, we can just say the refractive index equals to 1.50. It doesn't have a unit. So option A is very correct. So do not forget to hit the like button, click on the subscribe button, and tap on bell notifications so you can always get informed as we release the next video for your preparation. Question 55. Radio waves belongs to the class of waves whose velocity is about just the same thing as that of light, okay? And the answer is 3 times 10 raised to the power 8 meter per second. So the correct option is C. Question 56. A single force which produces the same effect as a set of forces acting together at a point is known as the resultant force. Option C is correct. Question 57. We have this diagram, okay? Which of the following statements about electromagnets shown above is correct? So, depending on where the pole or where this diagram is facing, okay? So, if you imagine that the current is flowing, normally conventional current flows from positive to negative, while electrons flows from negative to positive. So if we determine that the current is flowing, okay, from positive to negative, that means that that is in a clockwise direction. That makes this place our south pole. This end here makes it our south pole. Then this becomes our north pole. Okay, so what fits our explanation will be option B. When the current flows from A to B, the end A will become the south pole because of the clockwise direction of the movement of current from positive to negative. Okay, the end A will be the south pole and the end B will be the north pole. So option B is correct. Dear my schoolers, perhaps you need clarity or you need to ask 1 or 2 questions. I've provided you with the link in the description below where you can ask those questions right now. The link will take you to our website where several solution providers are waiting to give you the explanation that you need. So question number 58. Calculate the velocity ratio of a screw jack of pitch 0.2 centimeter if the length of the turning bar is 23 centimeter. This is very easy. Recall that velocity ratio is effort over load, and VR, velocity ratio, okay, equals, alright, L over P. Okay, this is also another formula for velocity ratio in this context for a screw jack. Okay, so we have 2 pi. Our L length is given as 23 centimeter over our P, the pitch is 0.2. Okay, from the question, I want you to confirm this along with me. We have to calculate the velocity ratio of a screw jack of pitch 0.2 centimeters. So that is where I derived this value from. Okay, I want you to follow me. So that means velocity ratio equals 2 times 23, that is 46 pi over 0.2. So this means 46 divided by 0.2 will give you 230 times this pi here. So the correct option is option A. So as you follow along through each of these videos, In case you see any question or steps you would like to elaborate on or share knowledge with us, we are very well pleased to listen to your recommendation. So please, in the comment section below, indicate the question number and the steps you would like to recommend. Question 59. The Earth's magnetic equator passes through Jos in Nigeria. At Jos, what will happen? So already the question tells us that the Earth's magnetic equator, or sometimes referred to the actinic line. Okay, so at that point, definitely the angle of zip will be 0. The angle of dip, rather, will be 0, because the locus of the point that has 0 dip is definitely the Earth's magnetic equator or the actinic line. So option C is correct. The angle of dip is 0. Question 60. A car moving at 20 meters per second with its horn blowing at the frequency of 1,200 Hz is chasing another car going at 15 meters per second. What is the apparent frequency of the horn as heard by the driver being chased? So this is very easy. So this is all about droplet effect. Okay, so just for instance, you are standing by the express and a car moved past you with speed and it hums. Okay, so you realize that the pitch of the sound continually decreases as it moves away from you. Okay, so that is just the dropping effect. So let's just pull it out. So for the source moving towards the observer or the man that heard the honking, okay, so the formula we're going to have will be the frequency which we are trying to determine, okay, equals the frequency of the horn from the source into brackets the speed of sound, all right, minus the speed of the observer, okay, over the speed of sound, okay, minus the speed of the source. This is very easy. So we have the, okay, I can call this F1 to separate it from this. So we have the frequency of the horn given at 1,200 into bracket the speed of sound in here, that is 340, okay, minus the velocity of the observer, which is 15, okay, over 340 minus the velocity of the source moving towards the moving observer, okay, that is 20. So I would have 1,200, 340 minus 15, that gives us 325, okay, into brackets 340 minus 20, that gives us 320. Okay, so we can do our further breakdown by saying 5 in 32, okay, that gives you 6, remainder 2, that is 20, 5 in 20, that gives you 4, okay, so that's 64, 5 in this gives you 6, 5 in 25, that gives you 5, okay, so we would have 1,200 times 65, okay, over 64. We can further break this down, okay, so we can say 4 here 16, okay, 4 here 300, okay, we can still say 4 here 4, okay, then 4 here 75. Okay, no more breakdown. So we multiply. So what we're going to have at the numerator will be 75 times 65 over 4 equals 4875 divides 4. When we multiply this by this, gives us 4875 over 4. When we divide it, we should have 1,218, yes, .75. Okay, so if we are going to convert this to kilo because of our options, so we should have something like 1.2 when we approximate this, like 22 kilo hours. Okay, that is the unit for frequency. So which of the options goes with our answer? That is option A. Option A is correct. So that is just it for this segment, but you know that there is still more to come. So do not forget to hit the like button, click on the subscribe button, and tap on bell notifications so you can get informed as we release the next videos.